7:30 is right.
Thursday?
Thursday?
Okay.
Sunday.
Yeah, but like I don't work on Wednesdays. I can tell. I'm just a sub for right now.
All right, I want you to go ahead and draw the picture and write down g of x so that as we calculate everything, when you go back to look at your notes, you have the picture to help you out. Things are really going to come full circle today. So what I want you to start thinking about is the relationship G has with the graph F. I want you to think about the relationship G of X, our function, has with the graph F. I'll go ahead and let you talk to each other first at your tables. What do you think about the relationship with G and F?
So anti, but it's from
So who's the antiderivative? G is the antiderivative of F. Yeah. So F is the 1. Okay. All right. Alex, what's the relationship happening here?
We got F is G prime.
Aha. If we look at G prime, if we take the derivative of our antiderivative, we get F of X. So since G involves the antiderivative, right, when we think about G prime, okay, F is the derivative of G. Okay, are we all okay with that? Okay. So G is what we call an accumulation function. Why do you think it's called that? What does an integral calculate? Area under the curve. So we call this an accumulation function because we're accumulating area under the curve from, in this case, 0 to x. Okay? So I want to work with G as a function and F as a derivative function. Okay? So let's first look at G of 1. Okay? G of 1 means we're finding the integral from 0 to 1 of f of t dt. Okay. Well, Dylan, what is the area from 0 to 1 under f? What's that area? Okay, so we have a triangle, height 3, base 1, so 3 times 1 times 1/2. Okay, so I'm asking you to find G. I'm literally asking you for what is the area from 0 to wherever. Okay, now what about G prime? G prime of 1. Okay. Well, remember, we just talked about how G prime is F. This is our derivative. So, Trenton, what is G prime of 1?
0.
Yes. I am asking you for the y value of the derivative. Well, this is our derivative graph, so we'll just take the y value. It's right there at 0. Questions on that? Okay. The second derivative evaluated at 1. Okay. Turn to each other and talk about what feature of the graph are we looking for if I want G double prime of 1. Talk to each other first.
Yeah, just listen.
But how do you calculate G double
So
prime?
it's just because it's going down. I thought you remembered semester 1.
Run suicides that you remember?
No.
Yeah.
Good one. Right, in basketball, if you don't have something like that, suicide, they're gonna go.
I would. So
Do you still run suicides? Like, do they call them that?
Yeah.
Okay.
What do you think they changed it? Times changed.
Maybe. Or I grew up in Portugal, so I don't know when I.
We've been running a lot of 16 and 1s this year.
That's a lot.
So on the sidelines, 16 minutes in 1 minute.
Okay, Xander, what feature of the graph are we looking for if I want G double prime? What did you guys talk about? Okay, well, we know that this is F, right? Okay. And if I'm looking for G double prime, let's do this. G double prime would be the same as F prime. Okay. So if G double prime is the same as F prime, then on our graph, I want to know what F prime of 1 is. Well, what does derivative mean? What's another word for derivative?
Tangent. Line.
What's, okay, instantaneous rate of change, slope, okay? The slope of the tangent line, okay? What is the slope here?
-3.
Okay? The slope at 1 is -3, okay? Let's process again why we picked out the slope. This is the graph of our derivative. So our second derivative is the derivative of the derivative. So I picked out the slope of the derivative. Are you with me? Okay. Semester 1's just coming back full force, isn't it? Okay, I want to know where G is increasing and decreasing. I want to know where function G is increasing and decreasing? I'll give you a moment to process with your group. Talk about where you think it's increasing and decreasing.
Oh, well, this is a lot.
So with G first.
I don't know where G is.
Oh,
So,
if it's increasing from -1 to 1,
Because when it's
decreasing
values
from
below,
-2 to -1, and positive 2.
because it's the derivative, so it's where it's positive.
Yeah. Good work, table 6.
no, it's negative
Take it over.
What do your friends call you?
Doesn't matter if it's
I don't care. I just
Like
don't.
sometimes French comes up.
I know.
Like,
Everyone says that.
yeah, but that nobody really calls it.
No, like none of the friends call me that. Like people that aren't supposed to be on.
Protractors are semi.
They think they're cool because they got you in your game, but not actually.
But like sports, for the most part, like teammates call me Brown. Some coaches call me Trent.
Well, that's what I got confused because Coach Clint had posted something about
Yeah, he
French bread, and so
always-
then I was like, dang it. And then I just get self-conscious and like, I don't know what to call you. So I'm just gonna call you something different every day.
Alright.
Okay, Max,
Yes.
where are we increasing?
We're increasing from -1 to 1
Why?
because that's where the values are positive.
Okay, the derivative of G is positive from -1 to 1, so that is where we are increasing. Excellent. Julia, where are we decreasing?
-2 to -1 and then 1 to 2.
Why?
Because that's where the
Okay, this is where the derivative is negative, so our function is going to be decreasing. Okay, now let's remember concavity. I want to know where G is concave up and concave down. 30 seconds to decide as a table.
Yes, constant. So -2 to 0.
So this is where it's increasing.
And
Okay, Heidi, where are we concave up? What? Okay. Okay, our derivative is increasing, which means our second derivative is positive. Okay? Which means, Allie N, where are we concave down? Okay? When our derivative is decreasing, our second derivative is negative, we are concave down. Okay? Trenton, what's happening at x equals 1?
we got a maximum.
And what's happening at x equals -1?
We got a minimum.
Okay, g of x has a minimum at x is -1 and a maximum at x equals 1. Now, since we've established that g is an accumulation function, we could actually find the value. Well, we actually did, right? We have a maximum at the coordinate 1, 1.5. Like, we can actually find the y coordinate now. Opens up some doors. Okay? One last thing before I have you start on your assignment. What if I asked you for g of -1? I'm asking you for the area from 0 to -1. That's like backwards, right? 0 to -1, is that a backwards interval? Yes, it is. So what is the area right here? That's 0 to -1. What's that area?
Negative.
Why did you say negative?
We're going backwards.
Okay, so that area is 3/2, but since we're going backwards, we have to put the negative on it. So underneath the x-axis, we have negative area, but then we also have to think about if we're going backwards, we have negative area under the curve. G prime of -1. What is it? Yep, 0. I'm asking you for the derivative value. Okay, so the y value of the derivative. All right, so I want to give you a chance to start this worksheet with your peers. Okay, we have like, what, 8 minutes left. If you can get through maybe a good portion of the front side, I would feel good about sending you home with the back side. Okay?
Oh.
Let's go.
Okay.
I don't know.
Well, yes, we didn't really learn anything new today. We are combining concepts from this chapter and last chapter. Okay? So we have a lot of items to think about here. Okay, the first 3 problems are just like the problems from your homework last night in the book, where I'm asking you for the derivative. Then we start getting into our accumulation functions with the graphs in number 4.
Will they always give us a graph for like tests and quizzes? Will they give us a graph?
Let me stop.